So, for those of you who don't know me, my name is Brent. I work for a company in town called Just Be Friends. We're making a social network, and when I met with Janice, our lovely CEO and founder, we sat down. She wanted me to be her director of technology to architect a platform for her. And being that it's a social network, it's very advanced, lots of relationships, I was like, well, you know, almost any database could do the job, but there's probably one that will do the job better than the others. And she handed me this guy's business card. It was just like, as if like, it was just a reaction. And so she handed me this Neo4j guy's business card, and I'm like, what is a Neo4j? Like, this makes no sense to me. So I looked into this. I just went home, I investigated it, looked at what graph databases were, and I'm like, wow, this is bang on. And it turns out that she had gone to a conference. She skipped some fancy, like, it's a California, like, pool party at some really swank house on the side of the ocean to, like, drag her rolly cart into this Neo4j graph database presentation. And they're like, you're in the wrong place. And she's like, no, I got it. Databases, right? And they're like, yeah. So anyway, she met all these people that made Neo4j. They were really welcoming to her, and they're like, if you ever need help with your product, you know, give us a try. So I looked it up, turned out to be perfect, and I decided on giving it a go. So this kind of led me to it. It turns out they're really cool guys, and I'll get into that in a little bit. So, graph databases and Neo4j. First thing, these are not graphs. Well, they sort of are, but not in this context. A graph is a general purpose data structure for interconnected information. This can be social networks, LinkedIn, Facebook kind of things. It can be navigation software like Garmin GPS, Google Maps, things like that. Family trees, the internet itself is a graph. Recommendation engines, like you can imagine on Amazon, it's recommending books to you, things like that. All these things are powered by graphs. Now, graphs are making some big news. We got Facebook Open Graph, we have interest graphs, and Google's launching Knowledge Graph, and Bing's trying to one-up them. There's all sorts of stuff, graph, and everyone's going on about it. Now, graph theory isn't new. In 1736, there's a man named Leonard Euler, and he came up with this problem. It was called the Seven Bridges of Königsberg. And the idea was that, there he is, and there's the bridges. So they had a city with these 4 islands, and they had 7 bridges, and they wanted to find out if there's a way that you can travel to each of the islands with only crossing each bridge only once. And so that was like the dawn of graph theory. They came up with an algorithm and a way to figure this out. It turns out that no, in fact, in this scenario you cannot, but his algorithm kind of led to an understanding of why, and it helped them redesign cities, things like that. And then in 1970, a guy named Codd came up with a relational model of data for large shared data banks. This guy worked with IBM, and this is way back, like dawn, imagine of the SQL days, things like that. This is all fairly new. And it turns out that he had this great idea for storing information as a graph. But IBM was like, well, we don't see much profit in this. We're already making money with SQL, so we're going to push. And then there was the birth of Oracle SQL. And graph databases kind of got put on the back burner for a little while. It's not giving me my notes, so I'm going by memory there, so don't quote me on that. So what does a graph look like, or what is a graph really? Well, if we take it up here, this is kind of like graphception. This in itself is a graph. Graphs are simply nodes with properties that have relationships between them. Imagine like a mind map. You've got points, you can assign them a name, it can just be a point, linked with arrows that relate all the points. And then you can have information under them. When you whiteboard a project, this is what you're doing, like just sketching out. Startup Weekend, our team made a mind mapping software based on graph theory. It didn't have to use Neo4j, it just saved us a lot of time because it was already built in the structure we needed. But anytime you just go out and you have relations, you can imagine yourself, your Facebook friends, things like that, that's a graph. You have friends, your friends have friends, it's a giant tree. So graph databases take this graph theory, and instead of a regular database, they're optimized for the connections between your records. So you have a bunch of nodes, lots of connections and relations between them. They're optimized for traversing that. They're blindingly fast at querying across these records. And they have built-in algorithms for finding paths through the data. There's a whole bunch of them, shortest paths, easiest algorithm. There's all sorts of fancy things in there, get very mathematical. I don't understand half of them, but when you use them, it's amazing and it does magic stuff. And they're whiteboard friendly. What you sketch out on a whiteboard for your application structure is exactly what it looks like in your database. And I firmly believe from using this that anyone who wants to mind map or like help their software team plan out stuff can use this software just as easily as any one of their developers. That's what's really nice about it. It is just nodes with lines between them. This is a great quote from one of the Neo4j guys. A relational database like SQL may tell you the average age of everyone in this event, but a graph database will tell you who is most likely to buy you a beer. So what is Neo4j in relation to all this? Well, Neo4j is the world's leading graph database, and from what I can tell, it really is. It's the first major commercial one that's in use today. It's designed by some awesome Swedish guys who love The Matrix and Doctor Who. Now that's why it's called Neo, named after Neo in The Matrix. And 4j is because it was for Java originally. So it's fully ASIC compliant, which means that when you put things in the database, you can expect that it's all in sync in real time. If you have multiple machines, you don't have data that's eventually ready. It's always there where you expect it. It supports transactions, so for developers this means that you can roll back your changes if you make a mistake. It can be built right into native Java apps. I don't know how, is there any Java app developers in the room? I don't really suspect there's a whole lot in the local community. We're all pretty web guys that run in newer languages. It can run standalone as a server. Now this is the critical piece of it. That's really awesome. And it offers a RESTful interface. So that's for all the developers in the room. Super easy to talk to it from any programming language. It has a beautiful web interface for looking at your data and traversing it. And it has plugins for almost any language. So PHP, Python, Ruby, Node.js, anything you can imagine has plugins for it. So why and when would you use a graph database like Neo4j? Well, SQL is really good for tabular data, things like spreadsheets, account systems, financial information, flat lists of data that have really light relationships between each other. The document store databases like Mongo, they're really good for complex key value documents, like giant sprawling documents where you can index and search the whole thing. Key value store things like Redis and Memcache are there for simple data that's typically temporary, but it's super blindingly fast for those tiny bits of information. And then graph databases for highly related data, like social stuff, mapping solutions, neural nets, spatial algorithms, things like that. They get really crazy. And one of my favorite things that's really popular lately is schemaless databases. There's no set structure that you have to define before you build your application. You can jam stuff into that database any which way you see fit at any given moment. You can go back and you can change things at any given moment. And in some ways it's a little dangerous, really screw things up. But it gives you the power of flexibility that in the future, if you want to add functionality to your software, allow your end users even some insight into being able to expand what they can store in your own database without having to program it all in advance and define these schemas and then worry about rolling out new schemas. You just put stuff in it and it grows with you. So really fast for prototyping, so I love that. Why is it also really good? Ridiculous amounts of data. Neo4j currently can hold 32 billion nodes with 32 billion relationships between them and 64 billion properties stored on any one of those, or not on any one, but all together stored under those types of things. That's a lot. And they're currently working on expanding this for big data. So this isn't big enough for them. They're working on trying to overcome those limits. So I figured I'd give you a little bit of a demo of how this goes. I'll have to pop open my browser for a sec here. So Neo4j itself has this nice little interface. And you just download it, you run it on your computer, you don't need dependencies, you don't need fancy installation stuff, you just run it. And it gives you this website with like a dashboard, shows you all your statistics, things like that. And you have a data browser. Now I've gone ahead and I've put a whole bunch of points in here. And I've never done this until last night. This is the first time I've ever done anything remotely mapped or spatial related, because everyone typically jams social networking data in these things. So like, here's my friends, and then the friends of them, tell me who we have in common interests, things like that. It's been done a million times. Hello World things. They, on their website, do the Matrix movies, and you can find out which actors played roles with each other in them. And the Matrix. They also have one for Doctor Who, of course. And so I put in a map of downtown. I know it's not too accurate in terms of the sizes or scales or anything here. But every one of these nodes is an intersection downtown, and each one of these lines is a road that connects it. Now you can't see it here, but I've actually gone in and named all these streets. And I've put in information for specific nodes for landmarks. So I put in Accelerate Okanagan is here, the pod is up here, the Canadian Legion, Home for Dinner, Mad Mango, and Safeway. So most of you are from downtown. You can kind of figure out which streets these are. So this here is St. Paul. This is Ellis. This is Bertram, and that is Bernard down there. So what's really cool about this now, if I just pull open my document for a second. I've saved this little query. I can show you guys, any of you developers later, kind of how this all works. I have a great quote from Steve at FreshGrade when I was working on the weekend, started a weekend with him. I was writing advanced queries in this, and he was watching me, and he's like, this is some sort of like magical fairy tale language. How does this work, and how are you getting results of what you're typing? Because once you learn just how to do it, it's so natural. Like, you don't have to keep going back to guides all the time, because he described everything with arrows, and you're like, well, start at me and walk down this path, and you basically describe to it which path you want to go down. And it just figures it out for you, and then you just format it however you want. So in this thing, I'll try to take over. It's really hard to see here. I can try to make the screen a bit bigger. Basically, I'm starting at 6, which is somewhere on that map down the corner there. I think it's Safeway. And I'm going to node 1. I'm actually going to change this. I think I'm going to go from 8 till 4, because I guess it's the most interesting results. But S is a start, E is an end, and you can find the shortest path from S using roads to get to the end. You use the relationships, and I'm extracting the names of all the roads as my route. Now, don't worry, it's a little cryptic to look at, but what's really interesting about this is if I switch this to list mode, and I run it, it gives me a list of all the street names to get from there, from Safeway, all the way down across downtown on the shortest possible. So it's just go on Bernard, turn on Bertram, turn into Doyle, stay on Doyle past one of the intersections, and then turn on Ellis Street. So I just made GPS last night in about 15 minutes. Mary Ann was there, so she's the only one who knew about that demo. So that is with no special plugins. That's just a base install. I just added a whole whack of nodes. They didn't have any meaning to them. And then I just added relationships between them saying, these are roads. And then I put names of the roads into it. And then I just visually, when I switch back to this, I drag them out, because you can kind of drag them around, play with them. You can even get it to lay them out for you. And it just visually shows you the relationships between everything. I just happen to lay them out like downtown looks, because it's easier for me to keep track of which number is what. Because I was 8 down here at Safeway to 4, I could change it, and I could say, well, you know, let's start at 6 downtown a little bit there, and let's go to the Royal Canadian Legion at 9. I can run it, switch back to my list. It says go on Bernard, stay on Bernard, and turn on Bertram. So it does that all in real time. That took 54 milliseconds to get that result back. So another example of this, you can import OpenStreetMap data into Neo4j. And OpenStreetMap has like an open source community-driven Google Maps, basically. It has all your geometry of your buildings, all your roads, all your parks, all your pathways, walkways, hiking trails, whatever in there. You can import it into this database, and you can query it in any way you see fit, and it's super fast. So there's Neo4j. I have a whole pile of stickers and buttons that I got from them. And if anyone's interested in actually like a technical sit down with it, the presentation, Neo4j has offered to sponsor one, so we can get free beer and pizza. So we're all interested. If you guys are interested, just let me know, and we'll figure something out there. So there we are. That's Neo4j in action.